Start out with terminology, the way that things are written, and the way things are presented. Do me a favor now. You can shut your Chromebooks down. We don't need them. Well, I'll pull them back up after you did all that. We'll pull them back up at the end to show you again how to load up the homework. But let's do this. In geometry, unlike some of the other math classes that you have, geometry has its own terminology, has its own, I don't want to say language, but it has a little bit of its way that things are written. And it's very specific. So what we do is, this. We have to talk about what are called, it's more or less how we want to label things. So geometry, what we look at in terms of high school is two-dimensional geometry. We do a little bit of three-dimensional stuff at the very end of the school year with volumes, but it's not so much the three-dimensional realm, if you will. What we're looking at is two-dimensional, what's called a plane, and we'll get to that here in a second. But do you remember what a point is?
It's a dot.
Does it have to be a dot?
No.
The dot is just the representation of it. But how about this? What is the definition of a point?
Isn't it like a point or something you just start with? I can't use this.
No, but you're on the right track.
Place where something starts and where it finishes.
You're on your that's really close. That's really close to what you're saying. What you're almost talking about is like a segment.
Yeah, that's
A start and an end spot, that would be a specific length of something. A point is just, plain and simple, a place in space. It's a place in space. It's somewhere. And that's where you were getting at with the idea of where to start. That's kind of where I think you were getting at. What we do with points in terms of geometry, what we do with those is we have to label them. Now, points are labeled with capital letters. We primarily use capital letters in geometry. Very rarely we use lowercase stuff. Oh, excuse me. We very rarely use lowercase. We'll use lowercase when we talk about lines from time to time, the cursive stuff. But it's just a spot. Okay? It's just a place, if you will. All right. What's a line then?
all right.
What is it?
It's like what connects the 2 points.
Okay, a line is what connects 2 points. So what you're saying is if I have 2 points,
Oh, that's a segment. Never mind.
all right, so fix it. You're on the right track though.
Isn't it like the thing that's in between? Isn't it like
That's a segment. You keep defining segment, which is good. But what would the line be then?
the distance from
Aren't all lines straight?
No.
Can you measure a line?
Yes. No, because it's infinite. It's infinite.
Infinite. Very good. A line is a, well, geez. If you squint just right, it looks straight. There. Yeah. A line then, a line winds up being a collection of points that has no end, if you want to think of it that way. And that's where you're getting the idea of infinity. All right. So a line is a collection of points. I use a lot of abbreviations without end. Collection of points without end, if that makes sense. Like you were saying, it goes through something. It has no ending. Now, when we label lines, it's Josh, right?
Oh, yeah.
So what Josh you were saying that he needed 2 points. And he's right. You've all heard this before, 2 points determine a line, because it tells you the direction that it goes. Being a singular point, if you have just a single point, you can go anywhere from there. By putting the other point out here, it's telling you that it's going to go that direction, or down here, or wherever. That's why they always say 2 points will always determine a line. Now, the way we label lines, obviously we're using capital letters. I'll just use B and C. And here's what you would write it. It's line BC. Any of you seen that before with the double arrow over the top? I'm assuming you probably have seen that before. You will see that for lines. What would be different if it's a second?
It wouldn't just be two dots.
Yeah, but you have to put dots on it? No, you just put it just a bar. You don't have to put if you put the dots on, it's fine. It's more often than not you won't see with the dots, but you're on the right track. Okay, very good. So there's your lines. We have points, lines, and then the last one are planes. And you guys are all sitting on a plane. You didn't know things fly in here? You know you can make things bounce? Really? You didn't know? Flat surface that extends in all directions. The floor. It's a plane. What's that? Yeah, exactly. A ramp is a plane. Anything that's a flat surface that you can theoretically continue on in all directions would be a plane. Yes, ma'am.
You go all the way up to the top of it.
1, 2, 3. Oh, you weren't ready? Is that right? Planes is where we spend most of our time in terms of geometry. When you guys are talking about y equals mx plus b, you were looking at a two-dimensional plane. You were graphing things in 2 dimensions. All graph paper that you guys have worked with are 2-dimensional. Those are just planes. All right. As you get into upper level geometry, not high school geometry, but geometry in college, if you go into like any real STEM stuff, you'll have to take some of the crazy geometry classes. You start talking about other planes that exist. You guys know what a sphere is, right? Yeah. A sphere is its own plane in geometry, in upper level geometry. You have what's called a gap plane. You have, I forgot the other ones. I really don't remember a lot of that class. I just remember that spheres are, I passed it, exactly. Spheres are actually pretty cool when you get into them, so, but we'll worry about that later. Now, a plane, you need 3 points that are not on same line to create. So a plane, you need 3 points to determine a plane, and they can't be on the same line. And there's a term for that, and we'll talk about that in a second. A lot of times people draw planes like this. They look kind of like a parallelogram. That's usually what people draw planes as. And then you just put 3 points in them. Points X, Y, and Z. They're not on the same line. 3 points that aren't on the same line create a what? A triangle. That's usually what we look at. And we'll just say, we would call this plane X, Y, Z. You can, this is one time that you use sometimes a single capital cursive letter to write it.
What's cursive, Mr. Murphy?
Where you sign your name. Sometimes they'll use that. Let's see if I can make a fancy K. They use fancy letters for that. They'll use a Q. Well, that's a G. That's a G, right?
It is a G. Wow. When you do a capital Z, that's like the most fun. I love them. I know, aren't they cool?
No, it's a 2.
No.
The answer is no. Yeah, sorry about that. So there's we get. So this idea of points that are 2 types of points. We have what are called collinear and non-collinear. And it's super easy to figure out what they mean. When you have things that are co-linear, co-dependent, it means that they're joined together.
It's from the back.
E pluribus unum.
Oh, that's from the two. Well, that actually is the-
A lot of our English words, you guys, that start with co or con, C-O-N, or con, C-O-N, actually are from the Latin con, meaning with or together. So, right? So collinear, you can actually see the word line in there.
Yep.
Right? So together on the same line.
Yep. This just means they points on, these are on same line. And what do you think non-collinear would be?
Different lines.
Not on the same line, right? Correct. Super, super easy stuff. Okay? Super easy. I apologize today. It is a lot of quick little definitions and stuff. There's not a lot of crazy things. Again, these are all things you know. You all know what they look like. All I want to do here is reiterate to you how we just write them out in terms of geometry, how you label them. Because that's kind of what we've got to make sure you know how to do. Which of those three is a ray? Sir?
The first one. No, the second one.
The second one, yeah. The second one. Why is the second one the ray? Yes, sir.
Because it's like it's a point and you want infinity only, but only the ray.
Perfect. Very good, very good, very good. Yep, this is the ray. The ray, not unlike a drop of golden sun.
We draw these.
Thank you, Ms. Barlow. She's humoring me, so that's all it is. You know why they call it a sun's ray? Because where does it start?
At the sun.
It starts at the sun and just continues on. So a ray has an endpoint, and it goes through, and like you said, through infinity. All right. The way that you label them, let's see, we are on BC. We'll use D and E. The way that you label rays is you just put the first letter is always the endpoint. The second letter will always be where it goes through. So it can be going to the right or left, doesn't matter. This would just be DE, and what you do is just put the arrow showing that it goes through it. ED would not be the same one. That would mean that it starts at E and it goes through D.
And what if you had another point there? What if in between D and E you had F? How else can you name that ray?
EDF. Death.
No? You gotta start with the endpoint.
Where does it
Start with the
start?
endpoint. Where does the ray start with? Starts at D. And which direction is it going towards? So you can write it. You only need two letters. Just DF.
I just need two letters.
Yeah.
The only thing you label with three letters are going to be planes and triangles. You only need two letters for these things. You only need two letters. Which one of those is a segment? Yes, sir. Last one, yeah. Last one's a segment, and the reason why we know this is the last one is the segment is because it has, yep, start and an end. It has 2 points, and there's nothing after it. It has a starting point and an end point. Doesn't matter which one's which. Nope. You guys all know that definition. It's not crazy at all. Segments have a start point and an end point and a bunch of points in between. The way you label them is the GH, and just put a bar over it. That's it. That's all you have to worry about doing for those. And like I said, this should not be anything new for you at all. So far, so good? So that means the last one was the first one on there was the line, which we already talked about. And I'm not too worried about that. Remember, sometimes you will see lines written as lowercase cursive. I'm sure you remember that, right? Say line L, little cursive L.
You don't have to draw
What's that?
a cursive.
It's something. Opposite rays. This is one that people tend to mess up from time to time. Opposite rays are basically two rays that go in opposite directions that create a line. Two rays that go in opposite directions that create a line. Excuse me. Sorry, guys. My kids are so full of the allergy stuff right now, too. We need more rain.
Let me know if you need some tea, because I have box.
Oh, that. What was that stuff called?
Dandelion.
Oh, that dandelion root tea? Opposite rays. Opposite rays are two rays that share a same endpoint, and they create a line. Opposite rays.
Like a train travel.
Yeah. Two rays with a common endpoint, and they create a line.
So, Mr. Murphy, stand right here and face the wall. And then I'm standing here. So we're on the end point.
I'm taller than her.
So what? So we're on the end point, and then we're gonna be opposite rays. Ready, go. Go, no, that way, opposite. Opposite directions, forever and ever.
Wait,
See how
And
that's
ever,
it?
and ever, yeah. You're like,
Okay.
you're like, peace out. I'm out.
That was her reason of moving in the past.
I know, right? So that, like I said, not crazy. You probably saw this one. You guys tend to forget about this. What? Sorry. Sorry. You can move. You guys can move closer.
You need to write, so you don't see what you're writing. You need to make. Wait, what's that? Fatter. What's that?
What's what?
Increase the
Words.
Two rays with common endpoint. They create a line. Yes, sir.
I should see how like the opposite rays. You should put it all the same thing.
You know what? The reason why I don't put that. My handwriting on the smartboard isn't all that great. If I start using that thicker font a lot of times, it just gets so messy. No problem. Intersection. Oh gosh. This is too much. We don't know what an intersection is.
Yeah, I know what that is.
What is it?
It's perpendicular.
Does it have to be perpendicular? No. How about this? Let's make an easier definition. This one sucks.
Oh, Jesus. What, were you trying to fight that in the midst of...
Intersection.
Oh,
Where things meet.
Where things meet, don't they? Hey,
I think that's the easiest way to write it. Where things meet. When two lines intersect, this is where we start thinking about what does it look like when two lines intersect. Remember in algebra, you guys did stuff in algebra where you did like y equals 2x plus 1, y equals 1/2 x minus 4.
God, I hate that.
And you guys would solve, the system of equations. You vaguely remember that? When you had systems of equations, you were basically looking at graphs. You were trying to figure out where two lines intersected. So intersection of two lines would be at a point. So two lines intersect. At a point. Two lines can intersect at a point. Two lines could be the same line. They could have infinite points. Two lines could be parallel if they had the same slope. They could not intersect. Two rays can intersect. What is this? You know what that is? Do you know if it's right angle?
That's an L.
No. How is one way to know? How is one way to know if it is a right angle for sure? You guys remember that rule?
You gotta
What is it?
do
Yeah. You remember how they would put that little box in there? That means for certain it's a right angle. If you don't see it, you can't assume it. Now, in this case, that's just called an angle. An angle is the intersection of two rays. Ah. Do you remember what this is called here? Where the two rays intersect? What does it create? It creates a vertex. We'll get into that later this week. You know this stuff, you just didn't remember it. Okay? All right. So you have two rays can create an angle. What about two planes? Two planes. It does, exactly. Two planes can intersect to create a line.
That's called an explosion.
Now, if you look at it, you're looking at the intersection of two planes at the front of the board. Look at the wall and the ceiling. The front wall is a plane, the ceiling is a plane, isn't it? And that crease right there, it creates a line. What's so funny?
You said two planes intersecting. I was like, that's an explosion.
That's what he said too. That's true. Whatever. Two planes can intersect and create a line. There's a lot of visual stuff that you can come up with. Oh no, I'll do that one. All right, let me see if you can do this. Draw me a picture.
This math class, not art.
But geometry is visual. Geometry is incredibly
What
visual.
if I'm blind?
Well, then I can't help you right now. But so far, you've been doing all right.
Draw me a picture of Braille.
Yeah, a plane intersecting with a ray. Draw me a picture of what you think a plane intersecting with a ray would look like.
Would that be a square in the line?
I don't know. What I might think of it would be something different than what you might think of it, but we all could be right. And that's what's crazy about a lot of this stuff with geometry, is since it is so visual, it's also kind of up to interpretation of what you believe occurs.
Oh, I know what it is.
Excuse me. Now, remember what I said that a lot of times people draw planes like this? Yeah. And what does a ray look like?
It's a line with a dot.
A line with a dot, okay?
Is it supposed to be sideways?
Doesn't matter.
I just asked.
Oh no, I'm asking back. Does it matter?
I don't know.
It doesn't.
Okay.
It doesn't. And that's just, it's usually what people draw, how they draw a plane like that, they usually just draw it as like a parallelogram, and usually parallelograms are drawn with that on the side. It could be squared, it doesn't matter. And that's the idea. It really doesn't matter. It's all, it's all up to your interpretation of what you think it looks like. And if it looks somewhat similar to that, fine.
That's a ray.
What's that? Yeah.
Oh, nigga, I drew it like, mine's like a tree.
Choose a picture of
Hold on, I got something funny. Hold on. Let's see.
It's probably like a teacher one. Yeah, it's probably like a teacher joke.
Alright, girl.
You know what I'm doing.
No. Oh my gosh. She was like, she's kind of nice about that.
I'm drawing you a picture of the aeronautical vehicle getting.
That's a snake on a plane.
Go with that.
Snakes on the plane.
Yes, sir. What's that? Guys, hold up. How did you place from the line? All right, look up. This wall here, that's a plane, isn't it? The ceiling fan?
No, there's a wall in the ceiling.
Thank you. But yes, when two planes intersect, they create a line, because remember, lines are infinite, just like planes are.
This floor not infinite.
It's kind of weird, that's the idea. What? Like draw it.
If I throw the wall out the window.
How about I do this?
It's not a phone.
I have mine.
Ladies and gentlemen,
What? I mean, yes.
those are two planes, aren't they?
No, that's 2 pieces of paper.
Squint.
Probably the same street.
There's two planes, and that grease line where they run into each other creates the line. I can't draw that. Does that make sense? No. Yeah. Or look on the floor, on the floor to the wall.
Did you
But
say
yeah,
planes
Look
are
at the
infinite?
floor.
This floor.
Yeah, look at the floor
Yeah.
and the ceiling.
I agree. It's very difficult to see an infinite plane that you're standing on because it doesn't technically exist. The only plane that you're standing on that does exist is a spherical plane because the globe is a sphere.
How could it be a plane if it's
Oh
flat?
my god.
Your book. Hey guys, real quick. I don't have that much left.
All right.
Your book talks about things that are called postulates and axioms. Don't write this down. I just wanted to explain to you when you see these terms, postulates, axioms, they're like definitions that you don't need to prove, okay? You'll see the term a lot. Angle addition postulate, segment addition postulate. They talk about axioms in terms of 2 points determine a line, things like that. It's just a geometry term for, it's a fancy way of saying math definition. Okay, so don't frequently see them. Yeah, it's a math addition. Yeah, I like that. So one of the things they talk about here, again, don't write this down. I just wanted to show you. They will call things specifically like postulate 1.1, postulate 1.3. They see how they drew their idea of what two planes intersect through, and they just draw the line going through it. I can't draw that to save my life, but I can grip a piece of paper and kind of show you what it would look like. But that's why they use these terms. Okay. This is yes, ma'am. What's that? Code. Oh, I don't have Google Classroom. No. I'm using the other stuff. The if you type in. So these are the problems I'm having you guys do tonight for homework. Now, what I want to show you, while you guys are all still have Chromebooks and stuff around, I want to walk you through how you get to the page itself in the book. And quite honestly, this should take you about 10 minutes, if that. Okay?
That's good enough for study hall.
Yeah, right? So, one of the things that I will do, I haven't done it yet today, is that, remember on the calendar, I will post these problems, not the actual page problem, like the picture of the page or anything, but I will put the assignment on the calendar so you guys can look at it if you failed to write it down. It will be on the board up here, and it will also be in the video notes. So if you forgot to write it down, you can always pull up the video note and scroll to the very end of the notes, and then you'll see what pages they were. Now, when we go back to the website, we clicked on geometry, and then we went to go to, yes ma'am. Yeah, grab the pass there. click the textbook, or I think most of you guys have it already pre-bookmarked on that as one of the apps, I believe, to get to the Pearson stuff, I'm thinking. What's that?
It's the home screen.
Yes, yeah, it's on the home screen there from just the Chromebook, right? Yeah. So click on Pearson, and then when you open this up, you have to do your authentication again. And if I believe once you type it in once, you can save the password. Only thing you'll have to do is just say that you're part of Cal 428. Log in. And then use your, I think it's realize, isn't it? Yeah. Then you hit the realize button.
Yeah.
Then we go to geometry. I think you have less clicks to get to it than I do. Hopefully.
So is it in a book?
Yes, sir. And that's why I want you to open it up now, Josh. That way you can screenshot it in case your internet isn't all that great later. And then you don't have to worry about being online to get to it.
She said she needs your assistance.
I'll be right there, Ms. Carr. So when you finally get to this, what page did I say it was on? 16? You just type in page 16, and then here's the problem page. Here's the problems themselves. So it's just a matter of some quick clicks like that. You can go backwards to get to some of the problems, but I will suggest that you screenshot those pages. That way they're there for you in case the internet does, have a hiccup. No. I only had specific problems. I'll put it back up there in a second. Yes, sir. And then you just type in your regular. Here you go, Josh. Yes, ma'am. Yeah, absolutely. Yeah, guys, if you want, now's the time. If you want to just take a picture of it with your phone, that way you don't have to pull the Chromebook out later on, that's fine. By all means, this is kind of what I hope that you guys will be able to do, because that's what I mean, I don't care if you're using your Chromebook or your phone, whatever, to get to the problems to do them, as long as you do them. Does that make sense? So take a picture of the problems here. If you want to take a picture of your screen, screenshot it, whatever, that's fine. All right? Oh, God, no. I'm doing those homework checks. So I'll look at it on those. I'll do the whole correctness of those 4 problems the day after a quiz. All right.
I had 2 classes.
Somebody actually make it
What's wrong?